Okay, guys, so this is the next video. We're still going to talk about scatter plots, but now we're going to give a little bit more meaning behind these descriptions of whether a line or whether a scatter plot is positive, has a positive, negative, or no relationship. And how we can give a little bit more meaning to those relationships is by finding a line of best fit. Okay, so let's go ahead and define line of best fit. It's a trend line drawn on the scatter plot that is used to best model the data. The line of best fit is used to predict future data. To write an equation of a line of best fit, we've got some steps here we need to follow. First, we need to plot the points on a coordinate plane. Then we need to determine the relationship of the data. Is it positive, negative, or no relationship? So we already know how to do these first two things. We did them in the last video. If the relationship is positive or a negative, then you can draw a trend line. Then we can draw a line kind of like we did up here. This is the line of best fit. Okay, we just are doing it more mathematically now. Then we can draw the trend line. That's what we call the line of best fit. If there is no relationship, the graph cannot have a trend line. So it can only happen if it's got a positive or negative relationship. Okay, so now we can draw a line of best fit that is close to the data points. Really, you want it through the middle. That's the best spot for the line of best fit. Through the middle, let's write that. Through the middle of all points. Okay, and so we want to write the equation of the line next. Okay, to find the slope, select any 2 points on the line. They do not need to be actual data points. So remember, to find slope, we can do rise over run, or we can use that's how we'll find the slope. Then we want to use the formula, point slope form. If you do not know the y-intercept, use slope intercept if you do know the y-intercept. So we've got a couple options, and we're going to practice both. And then we're going to use the equation to make predictions. This really ties everything we've been learning together. You've been working with slope and the equations of lines since last year. So let's practice. The graph below shows the relationship between the bicyclist distance and time. Find the equation of the line of best fit. Okay, so you can see we already have the trend line drawn in there in red. What we need to do is now write the equation. Okay, so let's first find the slope. Again, they don't need to be actual points on the line. We can just find them. So what I want to do is I'm going to kind of pick this point and this point because it seems like they're very close there. So I'm going to just do rise over run. When I do rise over run, notice this is by 20s here. So I'm going 20, 40 is my rise. And it's a negative slope. And then I'm going to run, and this is, watch our slope here. Watch our units. This is 1.5. 1.5. Let's get a number for that. We can do that. 40 divided by 1.5 gives me negative 26.67. Okay, so there's my slope. We can see we've got the y-intercept. Okay, and so we can see if we have the y-intercept, which equation we can use. The y-intercept here, the b value, we're going to call maybe, if this is 180, let's call it 170. So then I can say the equation is y equals, the m is negative 26.67, x plus 170. So remember, that's just y equals mx plus b. Okay, and so now we can use that line to approximate something else in the future. For approximately how many hours has the biker been riding if they have 80 kilometers remaining? So remaining distance, you can see that is the y value. And I'm trying to figure out what the x value is. So we're going to take the equation and substitute in what we know for y. So I have 80 equals negative 26.67x plus 170. Okay, so we're going to solve this for x. I'm going to subtract 170 on both sides. So 80 minus 170 gives me negative 90 equals negative 26.67x. Then I'm going to divide both sides by negative 26.67. And we get 3.37. And that would be in hours. So 3.37 hours remaining. Okay, that's how we're going to use the line that we find for the line of best fit. Okay, let's just try this one here. The table shows the weekly sale of a DVD and the number of weeks since its release. Make a scatter plot of the data and draw a line of best fit. So let's do that first. Let's plot these points. We'll have 1, 19, 2, 15, 3, 13, 4, 11, 5, 10, 6, 8, 7, 7, 8, 5. Okay, and so once we have our data plotted, we can now make our line of best fit, and drawing a trend line, we're just going to go through this data. I'm going to draw it pretty thin here. Through this data as best we can, all the points right down the middle of all the points. Something like this. Okay. Some points are above, below. It's a little bit even right there. Okay. Write the equation of the line of best fit. So let's first find our slope. And I'm going to find 2 points. We'll notice it kind of goes even here and here. So my rise is 2 and my run is 1. So my slope is -2. I don't know my y-intercept. So we're going to use point slope form. And we're going to pick any point on the line. And I'll use that 7, 6. I'll use this one right here for my equation. So y6, oops. So y minus 6 equals -2, x minus 7. We'll distribute the 2. And then add the 6. Here's my equation of the line of best fit. Interpret the slope. So if the slope is -2, that means the sales, because this is talking about sales, decrease because it's negative 2 million each week. Right? And this makes sense. When something first comes out, there's so many sales, and then the sales decrease over time. Predict the sales in week 9. So if week 9, I look at my graph, this is the x value. So this x equals 9, and I'm trying to find the y value. We're going to use our equation. Y equals, because I'm trying to find the y value, -2 times 9 plus 20. Y equals -18 plus 20. We get 2 million sales by week 9. So, and that makes sense. If you look over here, by week 9, we'll get about to 2 on that trend line. Okay? And then let's just check out this last question here. The scatter plot to the right shows 9 points from a data set. The equation of the line of best fit for the points shown is determined. Then 3 more points are added to the scatter plot, but the equation of the line remains unchanged. Which 3 ordered pairs are most likely added to the data points? So when we look at these data points, we want to pick points that wouldn't change the line of best fit. So right now, when I'm looking at this data, I would say the line of best fit is going to go right here. Okay, there's some points above, some points below. So when we add more points to it, it's not going to change. In fact, it's probably going to cluster up here or anywhere in this region. We would want these points to be. We don't want them anywhere else because then that would change my line of best fit. So let's go ahead and look at these points here. We've got 4, 4, 5, 5, like right away, 6, 6, like this isn't it, right? Those 3 pink points that I just plotted would totally change the line, the trend line. Okay, let's check out the next one. 4, 10, 4, 11, 4, 12. Well, that's pretty much what we have, right? So that's looking good. Let's just check out C is 8, 9. Well, we're all the way over here. So already I kind of know this isn't good. 8, 10, and 8 and 11. This would totally change the line, not C. And then one more, 10, 10, 10, 11, 12, 12. Those points would totally change the trend line, okay? So keeping it along and around the trend line is how we know we will have the same trend line and data that continues in a positive relationship, okay? Great job, guys. This is the last video on data displays. Awesome job.